Okay. So we are going to look at force on a differential current element. I'll tell you where we're heading. We're heading to transformers. So the force exerted on a differential element of charge, dq, moving in a steady magnetic field is given by dF equal dq times the velocity cross b newtons. Differential current element. So let's step back to current for a while. As we know, the current density J can be expressed in terms of velocity of a volume charge density as J equal rho V times velocity. So the current crossing a plane is given by a volume of charge crossing the plane times the velocity. Your differential element of charge can be expressed in terms of volume charge density as rho V dV. Tell me anyone who have a problem with these two. I've done them before. But it doesn't hurt if you forget to say you forget.
So that V is for volume, right?
Which
For
V?
the charge density. The dV. Second, last one. Last one.
The dV.
Yes, sir.
Differential volume.
Okay. Thank you, sir.
So what we're gonna do now, we already know these from before, right? So we're gonna substitute this in this equation. So dF equal rho V dV times the velocity cross V. Now, expressing dF in terms of J using equation 2. We get dF is J cross B dV. But we can have steady, we have already studied in previous chapter the relationship between current element are J dV equal K ds equal IDL. We know that. Thus the force exerted on the surface current density is given by that. All we are saying is that if it's not a volume charge, J dV, right? If it is this, if it's a sheet of charge, and we're using KDS, or if it's a line charge, we use IDL, whichever, such as this. So this is the differential force. So the total force you would have to integrate over the volume, which would be this. That's integrating this over the volume. Or 5 you'd integrate over the surface like this. Or if it's a line charge or line current, you'd integrate over the entire length. So then, this is where you have a problem. So if this is where you use ideal, all we are saying is that the normal component to the flow would be sine theta. So you would replace L cross B by B sine theta. So actually the magnetic field exerts a magnetic force on the electron, which constitute the current I. But these electrons are part of the conductor. This magnetic force gets transferred to the conductor lattice, works on the whole. So then, like I said, we are heading to transformer where we have inductance and mutual inductance. So we are starting now with 2 current elements, one here, one there. So we are going to look at the force exerted on one by the other if the current are going in the same direction or if the current are going in opposite direction. Just like how you wind a transformer coil. So just let us take a little time and go through this story. While discussing the electrostatic fields, we have studied that a point charge exerts a force on another point charge separated by a distance r. If these charges are the same type, both positive or negative, then they repel each other. But when 2 charges are a different type, one positive and other negative, they attract each other. Now consider 2 current elements, 2 current carrying conductor are placed parallel to each other. Each conductor produces its own flux around it. So each conductor, here is your current element, here is your current element. And each is going to produce its own flux around it. So when each such conductor are placed close to each other, there exists a force due to the interaction of the 2 fluxes. The force between such parallel current carrying conductor depends on the direction of the 2 currents. If the direction of both the current are the same, then the conductors experience a force of attraction as shown in A2A. So in A2A, they produce a force of attraction. If the direction of the two currents are opposite to each other, then the conductor experiences a force of repulsion as shown in B. Let us now consider the two current elements, I1, DL1. So here is your current going around. No, your current here. So your circular path is here. So I1, DL1. This is your DL1. And this is your I2, DL2. Both the current element produce their own magnetic field. As the currents are flowing in the same direction through the elements, the force DF1 exerted on element IDL1 due to the magnetic field DB2 produced by other element I2DL2 is the force of attraction. From the equation of force, DF1 is this. Right? According to Boyd-Savarot law, the magnetic field produced by the current element I2DL2 is given by, for free space here. So we're going to substitute now this equation back into this one. So we get this. And when we substitute and do the integration, we come down to this. This for F1 and this for F2. Okay.
Sir,
Hmm?
sir, sir, I wasn't really following this part of the topic, sir. So could you use one of the tutorial questions as a demonstration to or to use an example before before we get one to attempt?
Hold on a minute. Here's the thumb drive. It's not it. Why? Yeah, what you was saying now?
Oh, sir, sir, I wasn't really following some parts of the material. So I was saying if you could like perform or do the calculations for one of the tutorial questions before we get one to attempt.
You answer after?
Yeah.
Okay, till later.
I'm in class. I have to call you back. Yeah, I'm in class. I have to call you back.
I have to go drop off something at the cafe. Huh? I'll go drop off something.
Okay.
Sir?
Yes.
No, I was just checking, sir. I wasn't sure if you could hear us or not.
You just check in.
Yeah, just checking, sir. Just checking.
Okay.
You want us to attempt this one, sir?
Yeah, I was just reading it over. Okay. Yes. What? Yeah, start this one. Attempt this one.
H.
What yet?
No, sir, I'm still do it, but I'm not too sure, sir.
I'm Kickstarter. So an infinite current element, infinite extent current sheet with K equal 6 AY amp meter exists at Z equals 0. Conductive loop of radius 1 meter in the YZ plane, centered at Z equal 2 meter, has 0 magnetic field intensity measured at the center. Determine the magnitude of the current in the loop and show its direction with a sketch.
Sir, first thing first, sir. It said that there's a 0 magnitude intensity at the center. That's HS, right, sir?
No, man. That's
No.
H. That's
Maybe where is it, sir?
conductive loop
Yes, sir.
of radius 1 meter in the YZ plane, centered at Z equal 2.0 meter, has 0 magnetic field at the center. So K is will give you HS, and your loop will give you HL. And that is the one. So that's the one at the center. So H total equal HS plus HL.
I think I found HS, then sir, I'm not sure. I'm not sure how to find HL.
Right? HS, simply this.
Yeah, man, sir. Wait.
You get that?
No. How? I got up to that last part, sir, where you get times by the unit vector. How did it go from A? I'm not sure it went from AY to AX based on my calculation.
This is not times, this is cross product.
Oh,
Remember we go through that formula this morning for the sheet current.
yeah, that's what they put in, but I didn't know it was cross. I thought it was.
Yes, cross. So yeah, K is in the AY, and your normal is in the AZ. So AY cross A normal, your AX. AY cross AZ, your AX.
Yeah, yes, sir. That makes sense, sir. As in why my calculations is wrong.
So that's a straight plug-in from the formula this morning.
And then for HL,
This is your I.
the current.
This is your H for a loop. For the loop. This is your H.
Why is that did you? Oh no, I think I get why. So as in why it go from AZ to minus AX?
Mhm.
Is that's because of the cross?
Right.
Uh, and it's chosen
That's it.
opposite HX, right? Oh, because so I'm not fully understanding why exactly we choose to sign opposite HX.
What the problem?
Oh, to go in the opposite direction of the current sheet, sir. Or not opposite direction, but like because of the right hand.
The right, the right hand rule or the thumb rule.
Yeah.
You say it, no?
Yes, sir. Because the current going the direction shape would be going, yeah.
So it should be opposite.
Wait. Probably in the y direction. So fingers crossed.
This is this is HS, you know. See, HS is AX. So you're not gonna cancel out if you're not opposite.
Also, and then HT will just be those, no?
Eh?
Because it did say something about H total, so I wonder where that come into play.
Right, that's why it have the opposite to this.
Okay.
Make it 0. That will be in a different direction.
Okay. And then the answer is just current equals 6.
Mm-hmm.
I'm gonna get it there. Well, kind of.
If you look upon it fairly quiet,
I just a theory behind it without a kind of message with it.
yeah, but when you go over what we do this morning, you will see it. Let's see this one. Given H is that. Try that one.
field, blah, 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 square limits, so damn, I'm stupid.
Hmm?
Oh no, sorry, sir. Sorry, sir. I work my Circuital. Sorry.
Okay.
Sir, question.
Yeah.
How did they end up with AX? Because I understand 6AY and AZ, but not the solution with 3AX. I understand the 3, but not the AX. Or
You're talking way up here?
yes, sir.
AY cross AZ, AX.
Because it's a cross, the cross product, what do you call it? You have to cross product the two vectors.
Oh, okay.
We depend the other one, let's still depend on one there.
Say that again, sir?
I tell Michael, so we depend 316.
Oh.
Yeah, sir.
Sir,
Yeah.
the
You
value,
ready?
no, sir. The value of a is it's a distance
The value for what?
common A, where in HL equal I over 2A. Like the equation H equal I over 2A.
You still depend this one?
No, sir, I'm talking in to find A in this one to get the current. In the current,
This?
yes, sir.
So the value of what?
I was going to
This-
try to use this.
This AX,
Right. In H
this A,
given the equation H equals I over 2A times unit vector of
Uh-huh.
here,
yes, sir. So I was asking the A in the denominator,
is the radius
right?
of the loop.
So I was saying if I were to try to use the find the distance,
You'd have to use the area of the square.
I was saying if I could use the square root of 2 squared plus 2 squared.
Root of 2 squared plus 2 squared. The magnitude of that.
Which problem you doing? This one up here or this one down
No,
here?
P 3.16, sir. You want to know if you could use the magnitude of the squares here, the corners of the squares that we have. But I don't think so.
Oh,
What what you're talking about, Delo, if I would use it as the limit,
okay.
And I get request.
Alright.
Anybody can help me
And
understand the question?
Well, sir,
Mhm.
I'm not gonna lie, I'm not sure how to approach this problem myself because the method I was trying it not really worked, so I'm not sure.
Sir, how are you?
Anyway, chip out.
No, I'm not
Hmm?
take my chip out. I stop in my tracks because what the show. You know that.
Is them square here a dot product?
Yes, sir. I use that formula, but
Oh,
incorrect.
so I was close.
I use this incorrect big time. I'm a diagram wrong. Oh, boy.
And these ones because the y component is 0. Times 0 plus
Okay, 1 for 2 minutes. Go and penetrate that for 2 minutes. Soon come back.
wait, sir. Can you
Go and understand it.
I know mine, I get smoky, you know. Money. My love. All right, try this one now. Wait. You need the figure. Oh, yeah, I'll get the figure without me showing you this. Oh boy, 350. I think you need the figure. Because I don't have 355. But you know what a toroid is.
Yeah. I see it before, but don't know what it does.
You know what a toroid is?
It's the thing that have the wire spin around it and that have, it look like a ring.
Right.
A circle.
Take 1 minute to go look for one on Google.
Yes, I'm not sure I understand this one.
Ampere circuit law. The integral of h dot dl equal the current enclosed.
Yeah, I got that far. And then within the toroid,
A toroid is just a number of
toroid. Yeah, I looked up the image like they said, sir. There is the circular loop with the loops around it, sir.
right.
I wasn't sure how to like get that. So I was wondering if I was supposed to use a circular loop, the Ampere circuital law and a circular loop. But I wasn't sure how to go about doing that.
So, the only difference now is instead of one I is n times I.
Oh, so it's just that it's just
Everything
okay.
is the same as just one loop. You just multiply what you get for one loop by n.
Yeah, I guess maybe that's an overthinking, sir. Because maybe I wonder, maybe I think you need to integrate something and use and change the limits to the A and the C.
It's just one loop times n. Let's see.
Sir, could you, with in terms of,
Mr. Do was it, sir?
yeah, and so when you have H5 unit vector phi, H5 A5, is it, you consider that it's a circular object, so you just multiply the mag H times.
Above we find h for one loop, which we use I over 2 pi r, right? A5.
Oh, yes, sir. 2 pi.
So in this case, B is like R. And since it's a toroid, it's n times the amount of current.
And as you mentioned, so the DL would be defined by rho
The
equal.
what?
Sorry, the DL, the differential length. Could you show you got that part, sir? Or the determine
Oh
the
no,
differential
that's because it's a loop and the 2 pi B is supposed to be 2 pi R. So the circumference of a circle. That's all DL is.
That's all
The,
it is.
yeah, the circumference or the perimeter surface area or whatever. So in this case, since it's a loop, it's just the circumference of a circle. So that's why we use 2 pi B or 2 pi R.
because he was mentioning something about C and A, so I was just surprised I didn't see.
Oh, the C and A is just like limits because of how the toroid stay. It's trying to imply that there's no like magnetic force on the top or the bottom of the loops, just in the center. If that makes sense.
So
You understand what I mean, sir?
There is no you said there is no magnetic field at the
Like,
edges. I mean,
yeah, at the edges. But B is in the center. So this formula is for B.
and you wouldn't consider the external part of like
For this question, no. Because for this question, them say the upper and lower, as in the externals, are 0 for this question.
so just for clarification, I said A is the inner part of the toroid and C is the outer.
Like A would be the all right, if it's a loop, A would be like the bottom part of the circumference, and C would be the top part that is completely opposite of A. So the top and bottom. And then B would be in between those. Wait, I think I could draw what a
I got a picture of it still. It's just the circular ring with the wires wrapped
Ring.
on it. So
Yeah, what you can look at is one of those loops. That's what you can concern about first. One of those loops. So it's like you go take off one piece of those loops, one piece of that loop, and one of the circles, and analyze that. So the whole toroid have is like different layers. But what you're concerned about is the one loop that will wrap around the conductor. One of the loops will wrap around.
okay, and I got that part. It's really just the A and the C because I don't see where.
Yeah, don't worry. That throw me off. We never use the A and the C non-talk. That did throw me off.
Thanks.
Okay. Let's try this one. Before you get caught up a waste time. This one. This is a cross product in. This is a cross product in cylindrical coordinate. Hmm. So once you get that now, which cross product are one of the first thing we do. So since you refresh that, find J now.
carry that kind, cowboy. In that case, I'll have it up. What's that, sir? Information.
Sir,
What's his name? Name is Montague. Daniel Harrison.
Yeah,
you're going to find the del of H to find J.
the first thing we learned was del cross H equal J.
All right.
Sometimes he goes by the name Carter Dan. Killed a tenant farmer in his son in cold blood. Stole a man's plow horse. Man's wife tried to intervene. Took advantage of, killed her too. Ain't heard of him. Now, like I said, he was a different name. Had a bullet scar on his left shoulder. Right there. Now, Carter Dan ran with an outlaw named July Bully. May he rest in peace. He's dead. Yes, sir. How'd he die? Whispered in his ear. How was that? Heavy. Sorry, shot my damn foot. Settle now, mister. Come. Come on, easy. I got a family, mister. You're better off without you. Somebody that's a sheriff. Afternoon, gentlemen. Down's got a ban on firearms. Check him in. Get him back on your way out. You don't mind me asking, but how is it all of you go so well here? These men are deputies. Awful lot of deputies for such a small place, eh? What's his story? My manservant, he's harmless. Saved his life in Shanghai. Get up on it, like. You don't mind giving up those guns, do you? Absolutely. Law and order, I say. Sure. Now, I must tell you that I'm more than happy to cooperate. I can't say the same thing for my compadres behind you. Quite a batch of strays. I'll say a prayer for you. You know, a little prayer. Yeah, you'll make a hell of a rug. And you'll be murdered. by the world's greatest lover. All right. What's your aim here, mister? Well, I hear that there are some cowards running security here, so I figured we'd come down here and look after all this gold. Cowards? Blackstone, detective agents, cowards. Now, Blackstones are good. Union busting, back shooting, homesteaders, women, but you put them up against some real men that know what they're doing, you sure you don't want my gun? You do know who we work for, right? The force he can bring to bear. You tell Bo. If he wants his town, come see me. I'm being hurt. Let go. Come on, horse. Never don't shoot. I'm the bride. Clear vision! Clear sight!
So it's in the right direction. Um, yeah.
So before we get here next week, somebody pressure me to send the MATLAB problems. All right, so see you next week.
Wait, sir.
Hmm?
As in, you sent them already, or you're going to send them?
What me say? It says somebody pressure me to send them. But me not send them yet.
Okay, just checking, sir.
Sir,
Yeah.
sir, did he come to any kind of conclusion about the exam, sir? Because it was,
As it stands now, is a face-to-face exam.
because well, in the
Can
time,
repeat that,
the time
sir?
is kind of,
Huh?
You can repeat what you said, please, sir.
He's asking about the exam, and I said, as it stands now, it's still a face-to-face, but I might change it.
Yes, sir. If you ever did face to face, sir, time and where I believe, sir, will be a problem.
But you would be at school.
sir.
No, sir, the distance where I live.
Okay,
Yes,
well,
sir, because multiple people live more behind them places, sir.
yeah, well, I
Sir,
mean,
question, sir.
that
I
is
saw
either
them
here or
send-
there. Whether, if it wasn't a pandemic, you would still live in Westmoreland, right?
No,
sir,
them
they are
would
told, sir.
yeah, them would have been nearby, sir.
Yeah, well, you would just have to come up for one day and spend the 2 hours and go back.
I
question.
curfew, not, sir, I curfew.
No, there's no curfew now. I wouldn't set it in curfew time.
I mean, 8 o'clock a curfew, sir.
Wouldn't set it 8 o'clock.
No, I mean, at 5 o'clock, then put as a proposal time, no, sir, in the evening.
Yeah, well, if you want me, make it midday. So by 2 o'clock, you're done.
Sir, question. I saw them sent out a schedule for final exam, and your exam is scheduled on the 22nd of this month. Is that true, or it's due to change?
If that's the schedule, I don't control the schedule. If that's the
Oh.
schedule, I say no, that's it.
Why
No,
that-
no, sir. But when you want the test to be fair,
How long have you take now? You know, every year they don't have an exam timetable.
So you know, say whoever set the timetable, why no when them think about more well, why them not give it time to study to a little break, like a 1 week?
sir, some of the classes haven't really even concluded it, sir. So it's like the week after we get in what we were doing, just week past or so.
That's out of my control.
Yes, sir.
That's next week.
I stop bending the rules to students because anytime I bend the rules to students, I get in trouble. Whatever rules they lay down, we go by it.
one work key. It's only one work key then.
So, sir,
Managed because that why?
So, sir, when I give you the final proposal then for the test.
I understand what you mean by final proposal.
Going through, you say I did still stands for now, sir, face to face. So I mean, say when you're going to give me the final say.
By next.
All right, sir.
Sir,
Mm.
in this problem, sir, I see where we differentiate the phi's, we differentiate the sine phi. So because of that, we get the cos or whatever. But I'm not seeing where the row is going, sir. Like the row at the front specifically. I don't see how it got flipped up to the top.
Huh?
Because like 1 over row becomes minus row for this calculation.
Mm.
That's because of the cross product, right, sir?
Yeah, man.
All right, just want to make sure, because
Oh, sir,
Yes, there.
right, sir, just, seeing that we're not going to be having like a study week, I was just wondering if it would be possible for you to make like something we can, like a mock test or something we can
So
just to get a feel of.
so really and truly, we only have two. We
2 weeks, sir.
we have 3 weeks, but we have 2 weeks.
No, sir, you have 2 weeks left, sir, because your exam set November the 22nd at 5 p.m. on the draft.
Okay. So we have,
um,
so we try wrap it up next week. So you have 1 week.
boy.
Well, just hope for your best, sir.
No man. Oh, no good.
Why, sir? But the thing look rough still, you know, sir, because it's set right near to curfew time. I don't know why you do that still. Have your test in the night. That is completely near the evening hours.
True. I'm see what I can work out for the next. Uh-huh.
All right, sir.